Next, due to sudden release of magnetic energy and solar flares occur, and the solar flares poses a great threat to systems in space as well as on Earth, and we are exploring the potential of machine learning algorithms to predict the solar flare intensities. And the solar flare classes are there are four classes mainly. We are predicting the B class is the weakest class, C class is less weaker, M is strong solar flare, and X is the strongest solar flare. And we have also labeled N. We have also labeled N for the no solar flare classes. The our study is an extension to the our study is an extension to the works which is previously done, and we are just comparing the machine learning algorithms to decide which is the best algorithm for prediction of solar flare classes. Next. So solar flare occurs due to release of magnetic energy, and they usually occur around the sunspots. In the first stage, emission consists of soft X-rays, while in the second stage, high energy is released and protons and electrons get accelerated. Huge solar flares, can impact very much on the astronauts and other instruments in space, as well as they are very harmful for communication systems in on ground based technologies. And thus we are comparing to see which algorithm gives the best on which algorithm predicts the classes very good. Next. So before us, MG Bobra and S. Covidat in their work have defined the positive and negative classes of solar flares, and they have kept a time window for within which if a solar flare happens in an active region, they consider it as a positive flare, and if it does a solar flare does not happen within a time frame, then they have considered it as negative class. And they have implemented SVM algorithm to predict the classes on positive flares. After that, Cheng Liu and etc. Cheng Liu et al. Used random forest on the SDO-HMI vector magnetic field data, and they have used 13 feature for the prediction of solar flares. Next. Whitechain et al. Have implemented an autoencoder for image reconstruction and LSTM networks for solar flare class prediction for time series observation. They have performed a binary classification of flare and no flare using 20 sharp parameters. And Zhao et al. Have used a combination of long short-term memory regression model with a 24-hour time window. They portrayed the most efficient time range for predicting solar activity using sharp parameters under the LSTM architecture is within 24 hours of the prediction. Next. So these all existing works are mainly focused on two flares, M and X flares, as they are the strongest flares and are very harmful. But in our work, we have increased the number where we increase the number of class prediction, where we are also predicting B and C class flares, and we are also giving the label N if there is no flare occurring or the data comes, but there is no probability of getting a solar flare. So we have compared the existing supervised machine learning algorithms and different machine learning algorithms which are implemented which we have implemented are logistic regression, k-nearest neighbor, support vector machine, decision tree, random forest, and adaptive boosting and gradient boosting. Next. So the data set we used is from SDO HMI vector field magnetic data. It has 27 features, out of which we have considered 12 important features based on correlation matrix, and the features include parameters like total unsigned helicity, total magnitude of Lorentz force, total unsigned vertical current, etc. For comparison of the supervised machine learning algorithms, we have used performance metrics like accuracy, precision, recall, and F1 scores for predicting which is the for deciding which is the best algorithm to predict solar flares. We have considered F1 score as we have considered F1 score for predicting the best method, as in our case the false negative and false positives are of great influence. Next. Next slide, please. So our result analysis are we can see that random forest is giving very good precision score and very good accuracy, and other algorithms are comparatively giving low. Next. This is an overall result analysis where we can see random forest is giving around 90% of the accuracy, while the second best is k nearest neighbor, which is giving around 87% accuracy and precision. Next. So after comparing all of these algorithms, we conclude that random forest is giving is the best algorithm to predict solar flare classes, as it is giving the best accuracy and best F1 score, and the second best is k nearest neighbor, as it is giving a little bit good accuracy in comparison to other algorithms, and for even class B, k nearest neighbor is actually better than random forest. Here are the references we have used for our paper.
Thank you. Okay. Thank you, Aishwarya. So, audience members, do you have any queries for the author? Okay, so I have a couple of questions. So as you mentioned that in this paper you are making a series of comparisons of different algorithms. So what is the data set that you used? I kind of missed it, I think.
Yeah, we have used the data set from Stanford's Joint Center of Resource, that is an which is an SDO HMI vector magnetic field data set.
Okay, has the data set been used in any of the
previous yeah, it has been used in the previous papers, but
not all the papers.
Yeah, so and they have like used different features and parameters, and one of the paper have used 13 features, and their method for extraction of features were different, and we have used correlation matrix for the feature extraction.
Okay, and
and comparison of machine learning algorithms for solar flare class prediction.
Obviously, is it the case that the different algorithms are using different features in your work?
No, we have compared all the algorithms for the same features.
Okay, thank you. No more questions.
So yeah, I have actually one question. So all the methods that you have compared are quite conventional machine learning techniques, right? And in my field, specifically when I work with images, I see that the deep learning methods give better results compared to the conventional machine learning methods. You mentioned one paper that have used some kind of neural network, LSTM neural network. So can you just throw some light whether that paper reports better results compared to the conventional machine learning method, so that other researchers who might want to work in this, they can start from deep learning instead of starting with conventional learning. Yeah. So can you compare the 5 or 6 method to that particular paper?
Yeah, that paper has used images and SDO HMI vector magnetic field data, but we haven't used the image data set. Our data set was about parameters only.
Okay, so okay, fine. So you have used some non-image parameters or features, but will you say that deep learning method on images that conveys the information about solar flare performs better?
Yeah.
Okay. So if someone wants to do research in this field, they should probably start with deep learning methods on images.
Yeah, on images, anyway, deep learning methods perform better.
Okay. So that is what I wanted to say. Thank you, Aishwarya.
Thank you.
We have one more researcher with us here in physical mode from paper 183, and the presenter over here will be. Oh, so both the researchers will be presenting their work, Rishi Shah and Harsh Shah. The paper title is Dangerous Object Detection for Visually Impaired People Using Computer Vision. I invite both the researchers to present their work. Yeah.
So good afternoon, one and all present here. Our topic is dangerous object detection for visually impaired people using computer vision. The paper ID is 183. Harsha and me, Rishi Shah, are going to present this paper. Next slide. So one of the greatest challenge that is faced by humankind is the visual impairment. According to WHO, it is estimated that nearly 285 million people in the world suffer from this problem. So basically, in this paper, we present the idea of using machine learning for dangerous object detection to aid these people. A custom-built data set belonging to 5 different categories of objects was used in this paper to train the machine learning algorithms. The models have been tested in real-world scenario as well by evaluating them on a custom video dataset to gauge their performance in terms of accuracy as well as their ease in deployment. The performance of each model is discussed, and the most robust and the balanced model is suggested at the end. Next slide. So visual impairment means a decreased ability to see objects that causes problems even in day-to-day activities. So previously many such technologies have been developed to help these people, such as white canes, which are able to detect obstruction nearby, or smart cane, which use basically ultrasonic sensors to detect the objects and alert the user using vibrations, or the RFID technology, which basically works like metal detector. However, one crucial drawback remained throughout. None of these technologies was able to detect the type of obstructing object and inform the user about the magnitude of the danger that an object possessed. Hence, in this research work, we aim to accomplish this task of detecting the dangerous object nearby using computer vision techniques, so that it can help the user to know the type of danger better and to take the corrective action appropriately. So we have gone through a number of papers regarding object detection, and we found these papers to be most relevant to our field of study and have used these papers for a reference. So this is basically the proposed work. The dataset that we used for this training is training of algorithms is completely custom built. We have collected images from web scraping or manually clicking and annotating them from 5 different categories of objects, which we thought possessed the maximum danger to a visually impaired person. The categories of objects are sharp objects, danger signboards, broken glass, fire, and manholes. The dataset contains nearly 2,500 images, which with the dimensions 416 cross 416, and we've trained the algorithms on this dataset. The After training the algorithms, it is important to test them correctly. So to test these algorithms in a real world scenario, we basically use a custom video dataset that we have clicked on our own, and then this all the algorithms are made to are gauged. All the algorithms have been performing on this custom video set, and their performance is gauged. We have nearly 60 objects in this custom video that we created. The models that we used for this comparative study is YOLO V5. The first one is the YOLO V4, scale YOLO V4. YOLO stands for you only look once. It is one of the latest technology in the market, which was developed in November 2020. It basically works on the principle of regression, and it simultaneously anticipates number one, the bounding box, and number two, the class of the object simultaneously. The second one is the next category of the YOLO, which is YOLO V5 model. It is 88% smaller as compared to the earlier version of the YOLO, and it can handle enormous frame rate and has accuracy as almost as good as the previous model. The third one is the faster RCNN model. It uses number of convolution layers, so it basically is an advanced version of CNN, that is a convolutional neural network, and it is able to achieve magnificent accuracy. The fourth one is the SSD mobile net. It also basically works on the principle of neural network, and it uses primitive hardware for deployment. So it is one of the most easily used models to deploy in primitive hardware devices such as mobile phones, etc. The last one is the Detectron 2 model. It was developed by the Facebook AI research group in 2018. The models comprises of a number of architectures, out of which we use RetinaNet architecture. So this is an example of this is basically a collage of the images that we've collected, and we've annotated them. The class of the objects and the confidence index is written to each of them. The bounding box represent the class of the image and the confidence index.
Good afternoon, everyone. My name is Harsha, and now we will see the evaluating parameters. The evaluating parameters used, various parameters were used to holistically judge the performance of all models. First one is the AP score. To understand AP score, first we have to know the two terms, precision and recall. Precision is a ratio of correct predictions by the total number of predictions, and recall is ratio of correct predictions by total number of true observation available in the data set. Then the AP score is calculated by average value of precision across all unique recall values, and the AP score is utilized to calculate the mean average precision, which is used to holistically judge the performance of model, which is again combined with intersection over union. The intersection over union is the ratio of area of overlap between the predicted bounding box and the actual bounding box by the area of union of both boxes. Now we will see the result and analysis. For the first table shown here is accuracy of different models on image data set. The best performing model in terms of just accuracy is faster RCNN and Detectron 2. But YOLO V5 performed decent in terms of accuracy, yet having lowest model size and least training time. Now we will see class-wise accuracy of each model. Here, the faster RCNN performed best in 3 out of 5 categories, while the scale YOLO V4 performed poor in 4 out of 5 categories, yet performing best in fire category. All the model perform best in all model perform best in manhole category, while all models perform worst, or we can say poor, in broken glass category. Here is the accuracy of object detection on custom-made test video. Here the faster RCN and Detectron showed great accuracy, but their inference speed was very low. Hence, they can't be utilized in real world scenario. So the YOLO V5, whose performance is decent, but showed a higher frame rate handling capacity. Conclusion. In conclusion, on doing overall comparison, YOLO V5 performed holistically best in all judging parameters and is most suitable choice to be utilized in real world problem. Our work could be further extended into domain of visual question answer, which will help to answer about the surrounding to the visually impaired people. Thank you.
Okay, thank you very much to the authors or the speakers. Audience, do you have any queries? Okay, so if nobody has any queries, I would like to ask a couple of queries for the authors. So your work is about dangerous object detection. So in one of the slides, you have shown your literature survey table. So could you just summarize what you learned from the literature, or what from the literature what you used in doing this work? If you could go to the literature slide, please.
So basically, we've written the conclusion brief about each of the topics. The paper that we used for the first paper that we used for efficient multi-object detection, we found that it uses one of the models that we used, the YOLO V5 model as well, and we found the results to be better there as well for the comparative study. And even from the fourth model, the employing real-time object detection for visually impaired persons, the paper by Napi et al. It helps us to get a broader idea of how further it can be extended to audio assembling as well for project further to make the visually impaired person use the technology in an efficient way. Also, then these are the research papers that we cited, that are official research papers, and basically this helped to get us a better idea about how to approach the comparative study.
Okay. Okay. Another question. You have mentioned that you had annotated the data, and there was something called the confidence index. If you could go to the slide, please. Yes. What is the this number, a confidence index?
So basically, this confidence index is what the machine tells is how confident it is about predicting this class of objects. So if you can see, the manhole is 0.7, so it is very sure, almost 80% sure that this object is manhole. So that is the output that the algorithm gives, the classification as well as the confidence index, that how sure it is about this prediction.
Okay, so in this particular picture, these are the annotations made by the algorithm and not you.
No, not us. This is the test set. We've done this. We just annotated them manually, but we haven't provided confidence index for training. This is the output from the algorithm.
Okay, got it. All right. No more questions from me.
Yeah, so I have few questions. First, regarding your database. So you said that you have custom built your database. So first question is, all the images that I can see have one individual class in it, right?
Yes.
There is either only fire or only sharp
Yes.
object. Have you tried with multiple classes images?
Yes,
Okay. So do you find that your algorithm is performing better on one thing and another thing?
Yes,
Is it?
there's a difference. For if there are 2 or 3 classes, we haven't taken images which have 3 classes of objects, and we found the performance deteriorated when the number of classes of the object present in an image increased.
Okay.
But to train that, and we have web scripted and manually clicked it, but we did not, because the algorithm did not have enough images from 2 or 3 classes in a single image.
Yeah, so that brings me to my second question. how many number of training images do you have in your database?
2500 images we use.
2500 images.
Yes, so most of them are web script, and we have manually. Suppose a sharp object image, we have clicked it. Or that some of the images we have clicked it and manually annotated them.
Okay, so what I wanted to add is the distribution of images or classes are equal or
Yes, ma'am.
imbalanced?
We've taken the balanced data set. We've taken nearly 500.
Then
images.
why the can you throw some light on why the performance is better in one class, drastically better in one class compared to the other class?
Ma'am, I think that is because of the machine learning algorithm. Because if you see a manhole image, there is simple thing to learn. There is a circular bounding box. But for broken glass, it is much more complex because the glass is broken in a numerous ways. So a category of single image from that particular type of broken glass is different. For the manhole, most of the images were either circular or rectangle. That is the only shapes we got.
Also, ma'am, in video also.
And what about fire? Then fire also does not have a definite shape, but probably the intensity is helping.
Yes, the color contrast
Color
is,
as well as, ma'am, the dimensions also continuously changing in broken glass as well as for manhole it is a specific dimension which hardly changes due to camera angle change.
Right. So will you say that your performance will probably increase if you increase the number of images to train your algorithm?
ma'am, I think that we had, I think it might increase, but I'm not sure because we have already seen that we had overfitting the data, we have overfitting the algorithm already because we had enough images. Now the images were repeating after a certain point of time. So maybe the training accuracy would increase, but we did not find drastic difference on the test accuracy. But
Okay.
we are
Okay. Good work.
Thank you.
Next.
Hello.
I think we can move ahead to the next paper. Team number 36. The presenter is Seema Vanjiri.
Yes,
Seema
yes,
Vanjiri.
ma'am. This is Seema
Are you
Vanjiri.
present?
Yes, I'm present.
Speaker.
Is my screen visible? Hello? Hello?
Yes, you're audible.
Yes, you are audible. Please continue.
Yes. Thank you. Good evening, all of you. This is Seema Vanjire. Today's presentation for title Behavior-Based Malware Detection System Approach for Mobile Security Using Machine Learning with my co-author Dr. M. Lakshmi. And as I am a research scholar from Satyabhama University, Chennai, and my co-author is a professor in SRM Institute, Chennai. Okay. Today's abstract for today's presentation is in today's world the mobile security is critical not only for our society but also for the each individual because everyone carries mobile device which is with yes.
Could you put your slide in full screen, please?
Yes, ma'am. Yes.
Yeah.
Now is it okay, ma'am?
Yes.
Yes.
Yes, please go ahead.
In today's world, mobile security is very critical, not only for our society but also for every individual. Today, everyone wants their own mobile device, which has resulted in a growth in a number of Android users around the world. Every device with internet access interacts with a variety of applications, resulting in a large number of malware infections or dangers in a mobile home. Our strategy moving forward will be to keep everyone's mobile device secure. So using machine learning, we have created a model for behavior-based anomaly detection or malware detection system for Android mobile device. Now here in this model, we have used three machine learning algorithms one is a KNN, second one is a naive Bayes and the decision tree, which will result with a good accuracy. Okay. Now moving ahead with the introduction. In introduction, with the handheld technology advancing at an exponential rate, almost every advancement in a digital world is receiving more attention than ever before. This can be attributed in a large part to every expanding mobile phone ecosystem. So there are currently over 2 billion mobile phones device in use worldwide, including feature phones and the tablet. When it comes to the OS or the software that powers the smartphones, then the Google Android has emerged as the clear winner in the ecosystem, with the lion's shares of 80%, beating out Apple's iOS and the Microsoft Windows Phone. These are the two different OS which are considered in mobile phones. This success and the popularity can be attributed to the ease which Android allows developers to create applications, as well as its open source nature. With the popularity comes a darker side, Android flaws. Now, the Android flaws is like that many applications comes with a different hidden malware attacks. Okay, so our aim is to find out that hidden malware attacks by detecting behavior of an application, means by observing behavior of an application. Now, to detect the mobile device behavior, it is necessary to define the types of action that can be taken and the various types of data that can be collected, allowing for the reliable and valid measurements. The behavior approach concept is to analyze the application statically and the mobile device behavior at a runtime. Some assumption must be made when the designing and implementing a mobile application for this system. Like while designing any application, some features maybe comes with the previous similar applications. Okay, the user must have an Android phone. The user must install the application on his phone and then they log into the application. We must also consider some functional requirement about the user and the system. To begin application monitoring, means here we have to observe that application, we have to monitor that application, and we have to extract some features or the malicious features from that application. The data consists of a number of times the user opens the application, which is referred to as application opening time. The user spending the most of time on that application, shortcut for launching that application, and the viewing its details. Means we have to gather all the details of that application when it is used by user. Then for this paper, we have referred number of papers. We have for that and from that 9 papers, information is displayed on the screen. Next, in proposed work, we have used Rebin dataset. There are other dataset like EMBA dataset is also there, MalZ dataset is also there, then MalImage dataset is also there. But to detect behavior of a application or to analyze the behavior of a application, we have used Rebin dataset, which is used to implement this system in a pie chart. This system has some functional requirements. The proposed method can monitor all network and application installed on the mobile device. Furthermore, no additional hardware is required. The system restrictions are stated in this system, such as the fact that if a program crashes, we will be unable to obtain any relevant information about the installed application. This system has the potential to detect the user's stress level in a working environment in a future. Then the result analysis, we have, as discussed, we have used 3 different algorithms like a KNN, Navy Base, and the decision tree, which is used to implement the system. These algorithms are used to detect malicious behavior in a mobile device, and their accuracy is calculated. Now, the accuracy is calculated by using name-based classifier, which gives the highest accuracy with the 97.37, followed with the KNN, which gives accuracy 91.99, and the decision tree, which gives accuracy about 89.98. Then the next figure, which depicts the outcome of this conclusion in form of graph. Here accuracy is given in a tabular form, KNN, Navy Base, and decision tree, and the accuracy in form of a graph is shown through this figure. Then the next slide is about the conclusion. ML, machine learning models, takes a proactive approach to malware removal. However, as the previously stated, the feature extraction bit requires the significant improvement. For example, if the feature do not match closely in the training, a specific part of a malware may be avoided in the output. As a result, a rigid machine learning framework is always recommended to combat modern shape-shifting malware and the adversarial impact it can have on sensitive data. The following statement round out the approach for this system. In this system, we used KNN, naive Bayes and the decision tree algorithm to determine the accuracy of mobile application behavior. Among these algorithms, the naive Bayes algorithm is most accurate at detecting malicious behavior from the smart Android mobile device. This system now will be used to keep an individual Android mobile security which up to date and time. The design of the system will be modified in the future using AI and in-depth learning approach or in deep learning approach we can also further implement in this system. This type of a system data set may be limited for the future work, so we must use a more extensive and diverse data set like the Ember or the Malzade or Malimage according to what type of a malware you are detecting or what type of a feature you are detecting from the application. So based on that we can use a different data set. So here I have concluded my presentation. Thank you. For this presentation we have referred these number of references. Okay. Yes, I'm done from my end.
Okay, Seema, thank you very much for your presentation. If you could please keep your screen shared so that we can refer to the presentation.
Yes, ma'am. Yes. Huh.
Yes, okay, it's visible. Just one suggestion, since in your presentation you have mentioned the paper numbers, means the references, so correspondingly if you can numbers in your reference as well when you put in the slide, that would be even better, okay?
Yes,
Yeah.
ma'am. Yes.
You have given numbers, so at the end last slide, if the papers were given as numbers instead of bullet points, that would have been like the best, okay? So this is just a suggestion for your future. Okay. So audience members, do you have any queries for the speaker? Okay. So I'll assume nobody has any queries. I have a couple of queries. So Seema, this particular methodology or problem statement that you have proposed, is this statement proposed by you? By you, I mean by the authors, or it is an existing approach? You have like improved it.
Yes, it is existing approach. We have improved with the other different algorithms because in earlier different algorithms were used like linear regression or SVM, random forest.
Okay.
We
So
have
you have used yes, you have used KNN, knife base, and decision tree, right?
algorithms. Yes, using these three classification algorithms, we have improved that malware detection approach accuracy.
Okay, so you have a baseline as well.
Yes.
Okay, so could you just tell me what is the input to these classifiers and what is the output?
Input to this classifier is the features which we have extracted from the Android mobile application. First, we have to list out all the applications which are present in any Android device. Then from that list we have to means one by one you have to extract all the features from all the applications which are then that after feature extraction we have to classify that features, either they are malicious or the benign. So if it is comes in the malicious class, then we have to define or we have to conclude this application or this application belongs to malicious class. So
Okay, Seema, just could you give me one example of a feature? Like one of the features that you have used is what? From the app?
yes. For suppose for any image, or suppose for example in a WhatsApp application, if you send any robust image or that image with the some malicious data hidden in that, so if you get that image feature, means if you extract features of that particular image, then we can consider that particular application comes with the malware attack or the malicious attack.
Okay, Seema, thank you. You have
No, I
Yes,
don't
yes.
have any.
okay.
Can invite next.
Yes. Thank you very much for your presentation. We will move ahead to the next participant.
Okay, yes, ma'am. Thank you.
So, paper number 39. The speaker is Anshul Joshi. The title is Dyslexia Prediction Using Machine Learning.
Yes, ma'am.
Yes, ma'am. Hello. Good evening, everyone. This is Sumant Kumar. Our group ID is paper ID is 39. And Gaurav, can you please share the screen? Okay. I think screen is visible to you, everyone. Hello.
Yes, it is visible. Please go
Okay,
ahead.
ma'am. Yeah. So our topic name is dyslexia prediction using machine learning. Uh, our professor is Dr. Premanand Gadekar sir, and our teammates are Anshul Joshi, Mukul Chipa, Gaurav Mishra, Sumant Kumar, and Minni Vishwakarma. Can you please switch to the next slide? Yeah. So our contents are abstract. So here I have abstract introduction, literature survey, proposed work, result analysis, conclusion, and references. So here I will be explaining about the abstract of the day. So, what is dyslexia? Dyslexia is basically learning disorder issue, which is mostly occurs in children, small kids, or any person. It is basically where a person faces the issue of reading, writing skills. In the when he is a kid, he faces the words like jumbled. He is unable to read the whole words or any paragraph, or he doesn't used to imagine what it is written. So here we are taking. Here dyslexia can be recorded in two ways. First is our surface and second is phonological dyslexia. So the test of pursuing the word is a surface dyslexia, while phonological dyslexia is a issue of investigating a part of a word. So in a phonological method, if you see, it is an indicator that is used to detect a disease before a kid can read it. Means before reading we can predict the disease of that, yes, if he is having. So with the current effort, we are basically aiming to produce a software or tool that a parent may use before their children can determine if a child is dyslexia, he is a dyslexic symptoms, like it is present in him. In this, we are using the techniques that are SVM, grid, search survey with an accuracy of 97.42%. So next slide will be explained by Anshul Joshi.
So good evening everyone, my name is Anshul. So here's the introduction of dyslexia. So dyslexia is defined as language problem including reading, writing, orthodoxy and speaking. So the task assists with building supporting innovations that can help people to perceive dyslexia early only. So dyslexia can develop due to impairment of phonological processing, and dyslexia is commonly find in children's, like 1 in 5 kids is having dyslexia. And dyslexia should be possible by considering a few factors, like patients turn of events, instructive issues, and clinical history. The task assists with building supportive innovations that can help people. We can find that the person is dyslexic or not. So the diagnosis of dyslexia should be done by this application which we have created. So Mukul, can you please tell the literature survey?
Yeah, good evening everyone. My name is Mukul Chipa. So we have done literature survey on couple of researches like from the Alex Fred and others used an improvement of EEG algorithm for classifying persons into regular or dyslexic readers. For feature analysis and extraction, they used support vector machine and Pereira and others used EEG based analytical work to predict dyslexia. The electrical activity of disadvantages of EEG and proposed optimization strategies to predict dyslexia in some of the best ways. Iwabuchi and others explores how people may easily monitor their challenges in reading, writing. This research includes a tool for evaluating URAWSS, which stands for Understanding, Learning and Writing Skills of school pupils prediction using machine learning. And Rello and others, a factual model was worked to separate dyslexic pursuits utilizing visual following from control pursuits. Eye tracking is performed by eye tracker, the binary classifier with 10-fold cross validations with the accuracy rate of 10.18%. Next slide. Gaurav. So here's our proposed model. So we took data set and split it into training data set and test data set. So we use some algorithm for comparison like SVM linear, SVM grid search CV, SVM RPF kernel, random forest classifier, and then we perform extraction, augmentation, and finally prepared for the results and predicted whether a patient is having dyslexia or not. Next. Now Gaurav will explain the result analysis.
Yes, ma'am. Ma'am. Hello. Yes, ma'am. So, ma'am. So, ma'am. Next is ma'am result analysis. Ma'am, after the ma'am purification and preparation of information for unique, ma'am, we have declared that SVM we have used 5 different algorithms like support vector machine linear search and SVM linear search and SVM kernel search. Next is SVM using grid search. So ma'am, all the ma'am, and next is ma'am random forest classifier. We have used also ma'am random forest using grid search. All the 5 we have used, we have found that the SVM using grid search we get actual of 97.42 accuracy. So we have implement the SVM grid search. So ma'am, in the data set is fabricated utilizes more than 500 tests and overviews. It is allocated into the 2 section, preparing set and testing set. Ma'am, actually 70% is utilized for preparation of models and 30% for information is utilized to test models. So ma'am, basically ma'am, in our project we have created a web view app. In this we have created some question answer to taken by the parents to answer the question for the children. According to that, we have calculated we have calculated and created the data set, and according to that we have predicting the children has dyslexia or not. So, ma'am, next is ma'am, we have using support ma'am. As you can see, ma'am, we have using 5 different SVM linear search, SVM RBF, and SVM grid search, and random forest, and SVM random forest using grid search. So ma'am, in this total 5 where we have using 5 different matrices like precision, precision, recall, and F1 score. So ma'am, in this we have get SVM grid search with a total best value like this. Ma'am, can you see the graph? The value of the precision value is upper level from the all the SVM linear or RBF kernel. So ma'am, we have found that the SVM grid search is found best value, and the model we have created which give the best value. So ma'am, conclusion is that the dyslexia is phenomenal trouble. So it was discovered that trial of the difficulty and rise time was the best indicators of kids and dyslexia. So ma'am, SVM grid search was found the most accuracy like 97.24. Ma'am, the tool was described and implemented. Debated portion need to be improved. And we have also the CETA early intervention program include the expertise of formal awareness. So ma'am, their theory is correct prediction of the matrix structure has to do with the fundamental authority prescription to the increase in time with phenomenal and literacy growth. So ma'am, mainly children with development conditions attend music classes, therefore the stamina frequency associated with disability is less common for children with dyslexia. Dyslexia is in music therapy. That's all.
Okay, thank you, speakers. Audience, do you have any queries? Okay, no queries from the audience. The speakers, I would like to ask just one question. In one of the literature survey papers, if you could go to that particular slide, you have mentioned that there are some disadvantages of EEG. Yes, in the second paper, Pereira et al. So, do you know what are the disadvantages? I didn't understand that point. Means why we cannot use it for dyslexia determination?
Mukul, can you please tell?
Okay, so actually we are up with our time as well. I think we'll end your presentation here. Thank you very much. We will move on to the next presenter. So the next paper presentation is from team number 40, and the speaker is Mansi Fute.
Yes. Hello.
And the paper title is a survey on ML in lithography.
Yes.
All right, your screen is visible. You can start your presentation.
Okay. Hello, good evening, everyone.
You have 10 minutes.
Yes.
Mansi. Okay.
Yes. My name is Mansi Fute, and these are all my teammates. And my paper is on a survey on machine learning and lithography. So, transferring geometric patterns from masks to resist material is what is called lithography. It's critical when it comes to the efficient functioning of circuits, and it's very important to increase the efficiency of this process to minimize the errors so that we can maximize the yield. And machine learning is something which is being used right now to optimize this process. And one major issue which is faced by machine learning in this is the issue of false positives. We'll talk more about it in our discussion. So lithography is a very important process in the entire fabrication process. Wrongly printed masks can cause open circuit, short circuit, and such other failures. Hotspots are ML has many applications in lithography like hotspot detection, OPC, SRAF, that is optical proximity correction, sub-resolution assist features, etc. So, but the most important one is hotspot identification, which is the one used most widely. There are 4 different types of hotspots, as you can see written over here. There's vertical bridging, vertical pinching, horizontal bridging, horizontal pinching, as they come up in different patterns. So there are four major types of detection which are used. The first is lithography simulation, in which the entire process is simulated. This is very accurate, but it's also very time consuming and very resource heavy, so it's not preferred a lot. The second is pattern matching, in which we feed the models data, and it matches according to seen patterns. So it's very fast, but it also doesn't work well in unseen data, which is its biggest drawback. The third is data clustering and machine learning, which is used most widely. However, in machine learning, there is one big drawback, that it causes a lot of false positives. So that's why the fourth method is also used, which is data clustering and machine learning along with pattern matching. So we'll talk a bit about the first step in machine learning, which is feature extraction from the mask. So here, the first type of feature which we use is density-based features. The density-based features is one in which the entire mask is divided into an n by n grid, that is a square grid, and then the value of each of these grid cells is calculated. The value calculated is the area of the mask divided by the area of the grid. So as you can see, the value will lie between 0 and 1. And where the density is higher, those portions are more susceptible to hotspots. Then we come to the next one, which is topology-based features. There are four types: the internal features, external features, diagonal and segment features. So in the right-hand side, you can see that there is 1 and 0. So the 1 is called geometry and 0 is called space tiles. So in this, the internal features are the width and height of the block tiles. The external features are distance between two adjacent block tiles. Diagonal are the diagonals between the convex corners, and the segment features are those features which which tell us whether the tile has 2 or 3 sides touching a window or any other space type. However, the third type is the one which is the most efficient feature, which is called concentric circle area sampling. In this, 8 feature points are taken on a circle, and those feature points are either taken as 0 if it's in space or 1 if it's on the geometry. And this is considered to be the most efficient feature, and it's shown to give the best results. Before we move on to types of models, the data set which we have is very important, and small data can lead to false negatives, which is fatal when it comes to hotspots, because even a single hotspot can can prove fatal to our entire circuit. So that's why it's very important that we don't have false negatives in our model. And to increase the data set, there are multiple other options which are used, like hotspot upsampling or data augmentation. Now moving on to the types of models. SVM and ANNs are things which all of us are familiar with, I assume. That in SVM we have the objective is to find the best separating hyperplane for the data. ANNs are multi-layer perceptrons, and the weights of these layers are manipulated in a way to give the best possible output. In CNNs, then the next type of models which are used are CNNs. CNNs are used very widely for this application. CNNs, they have 4 layers: convolutional layers, pooling layers, fully connected layers, and ReLU layers. However, pooling layers are sometimes dropped. We'll talk about it in our discussion. And then moving on, we have ResNets. ResNets are a type of ANN in which the input is added to the convolutional output to give the final output of the cell. You can see the diagram on the right hand side. The input is added to the convolutional output, and we get the final output as fx plus x. The next ones are Gaussian process. So, and GAN, that is General Adversarial Networks. Yes.
Mansi, you have 2 minutes left. Okay.
Okay. We'll move on to discussion then.
Sure.
Okay, so to discuss some issues and some solutions about these methods, ANN and SVM have a problem of overfitting, which can lead to higher number of false alarms. As we talked before about CNN, that it consists of layers like convolution, pooling, fully connected, and rectified linear units. So the performance of CNN can be improved in this case by not including the max pooling layer, as the pooling layer makes it more generalizable by reducing small variations in the input. Out of these, the performance of SVM can be improved by using Gaussian process, as it will provide a confidence metric about the result. It improves the accuracy by around 28%. Next is ResNet. ResNet has been found to work very well with false positives problem faced by usual ML algorithms in lithography. The performance of both the CNN and ResNet drastically increased by using transfer learning. The next is CycleGAN, which is used for hotspot correction using image translation. Its main objective is that the training can be done in an unpaired manner. Hotspot correction is typically an application that needs a dataset of paired images, which can be a bit difficult to prepare. CycleGAN involves automatic training of image-to-image translation models without paired examples. And the next is data augmentation in ML OPC, that is ML in optical proximity correction, which uses a multi-layer perceptron. One of the limitations of MLOPC is that the lack of diversity of training clips. If the clips that correspond to empty regions of the space are provided to MLP, mask bias predictions becomes inaccurate. So this can be solved by using data augmentation in the training process. Next, so to conclude, as we discussed that data augmentation can be used to increase accuracy, ANN and SVM have a problem of false positives. CNN and ResNet improved drastically after using transfer learning. Then for hotspot correction, CycleGAN can be used, and we have compared the standard feature detection techniques followed by the machine learning techniques that are used for further classification. And we have also covered multiple applications of lithography in VLSI fabrication like hotspot detection, hotspot correction, OPC, etc., with details and with multiple solutions for each application.
These are the references that we used.
Okay, speakers, thank you very much for the presentation. Audience members, do you have any queries for the speakers? All right, so no queries. From my side, there are no queries.
So I just want to ask one thing. When you did the literature survey, did you find any standard benchmark data set for this lithography process or fault finding process? Are there any benchmark databases?
People have used databases like the N7 and N10 databases, are the two names that we could find in our literature survey.
Okay,
they were used pretty widely.
Yeah, so one suggestion is that it would be better if you can include it in your presentation. So it will be like one place solution for the people who want to do research in that. So they will, along with the problems and the areas where the knowledge gap is there, they can know that these are the databases that we can use for our research.
Okay.
So that is all from my side.
Okay, thank you so much. We'll make sure to do that.
Okay, speakers, thank you very much. We will move ahead with the next presentation. It is paper number 41 and the speaker is Nitish Thorat. The title is an e-commerce medicine website deployed, no AWS with precision verification. So please share your screen.
Yeah. Yeah, is my screen visible?
Yes, it is visible. Please go ahead and limit your presentation to 10 minutes.
Sure. So, hello everybody. Our presentation title is an e-commerce medicine website deployed on AWS with prescription verification, and our paper ID is 41. The authors' names are, as you can see on the screen, Nitish Thorat, Yash Punna, Jay Narayane, Saurav Ajay, and Geeta Navle. Moving ahead, this is our abstract. So, what this project particularly aims is that to develop an e-commerce website that offers medicines and drugs with the feature of connecting the customers with their doctors using simple web development tools. So we are going to connect the doctors and the patients on this particular website, and on this website we are going to give the feature to the doctors to write the prescriptions for their patients. So the doctor can write the prescriptions over this website, and we are going to check whether the doctor has been authorized to do so. And for that, a prescription parser will also be created, and we are going to make the prescriptions, and the prescriptions will be signed and verified using the RSA algorithm, and similarly they will be encrypted using the SHA-512. So it checks whether the integrity of the prescription when the doctor wrote the prescription is same while the patient is downloading it. So we'll look into the details in the further slides. And this website will be deployed on AWS using the various services that AWS provides, like EC2, RDS, and S3. And a round of penetration testing will be done on the website as well. So let's move towards the introduction. Why did we come up with this idea? So as you can see, last year the pandemic hit us and it was a surprise for everyone. And even going to the hospital was dangerous enough because there were no availabilities and the COVID patients were everywhere. So we came up with an idea that we can have a platform where the patients can connect with their doctors virtually, and even the prescriptions can be written on this website as well, and the medicines can be ordered using the same prescription. So that was our main motivation, and it is a step toward a better healthcare system, we can say. Moving ahead, so this is our literature survey. So here we have many more papers, but we have included the most important ones. The first one is for an iShop, a model for smart shopping, which has an e-commerce website, and they are using a lot of e-commerce tools, which we have also used in us, like normal web development tools, the payment gateways, and all this stuff. The second one is optimizing data storage and handling dynamic input fields with JSON string compression. Now the JSON string compression is used for the prescription data that we are handling. It is stored in the JSON string, and it is manipulated from the Python scripts and all this stuff using the JSON string, and we are creating the prescriptions using this JSON string as well. The third one is deploying an e-commerce website on Amazon Web Services, because we are going to deploy the website on AWS, so that's why this paper is relevant. The next one is implementation of storage in virtual private cloud using simple storage service in AWS. So to deploy the website on AWS, we will be creating a virtual private cloud. We'll see that in the system architecture, and for that we have included this paper. The next one is analysis and impact of vulnerability assessment and penetration testing. And in this, various VAPT tools like Burp Suite and all those things have been mentioned, and that we are going to use. Moving ahead, this is a system architecture. Now I'll explain you that the top field is the website and the bottom field is the virtual private cloud. Let's move towards the website first. So first of all, the doctor will be authorized on the website using their government ID and the medical license and stuff. Then the customer will register on the website, or will be already registered, and the connection between the doctor and the customer will happen. Just like in any social media sites, we see a request will be sent and it will be accepted on the other side. Then the doctor can write the prescription on for the customer in a proper PHP form that we will be providing, and from there the prescription will go through this parser, and the customer can use this prescription to place their order. Now the below part is the virtual private cloud. It has two public subnets and two private subnets. Public subnets will have the EC2 instances on which the website will be deployed. It also has an elastic load balancer to handle the traffic over the website, and there will be an internet gateway because we want website to be accessible to the people. There will be a virtual gateway for the private subnets where our database and the prescriptions will be stored, where the database and the administrator can handle the fields. Now let's dive into how the prescription is getting created and how it will get stored. So first of all, a PHP form will be provided to the doctor, where the doctor can write all the stuff of the medicines and all the things like the quantities and all those things. Now from there, a JSON string of product keys or the primary keys and quantities will go to the MySQL prescriptions database and get stored there. Another JSON string of prescription contents will go to a Python script which will create the PDF format of that script. So the PDF format can be downloadable, or the user can directly use the prescription online to buy the medicines from the website itself. Moving ahead, the prescription verification. So how the prescription verification happens, we'll know when the doctor creates the prescription. First of all, it will get signed and hashed using the RSA and SHA-512 with a private key. Afterwards, the prescription will be fetched by the customer, whoever wants it. Now here the verification, actual verification will happen, where it will verify whether the fetched prescription and the signed prescription have the same contents using the SHA-512 public key. If the contents are the same, then it will go ahead and verify some more conditions, like whether the doctor was authorized, the doctor and the patients are connected, the person downloading the prescription is the exact person the prescription is assigned to. If all those things are verified, then the prescription will be verified. If any of these conditions is not satisfied, the prescription will not be verified, and the patient cannot order the medicines from the website, or the thing won't be downloadable as well, so you won't get a chance to get it from the local stores as well. So this is how the verification works. Moving ahead, the result analysis, we have added how the prescription will look when the doctor creates it. It will be unverified at the time because the customer hasn't downloaded it or hasn't used it. So here we can see the prescription will look like this. The patient's details will be here, the doctor's details will be here, the medicines will be here, and it will be color coded for the time ranges in which the medicine needs to be taken. The quantities will be there, the extra instructions, if there are any extra instructions, any specific details the doctor want to provide, it will be there. And this particular thing is the unverified sign, because it has not been verified yet by the customer by downloading it or using it. So this sign will be there. The next one is the verified prescription. So whenever the patient is downloading the prescription or using the prescription to order the medicines, the verified symbol will come up. Yeah.
Sorry for the interruption. You have only 2 minutes left, okay?
Yeah, sure. It's just the last slide. So whenever the prescription needs to be downloaded or it needs to be ordered, so this particular verified symbol will say that this prescription is verified from the website, so it is safe to use this prescription. So that is the whole point of this. Now the conclusion. So what do we have here is that a web application for buying medicines that can connect the doctors and the patients with each other will be created. The doctors can create the prescriptions through the website using the interface provided to do so. There will be a PHP form, like I said, and it will be verified using the RSA algorithm and the SHA-512 hash module. Then the user can download the prescription or order the medicines from the website itself, and the user can use the prescription to buy medicines from the website or can use the prescriptions at a local pharmacy using this prescription. So that was the main idea of our presentation that we wanted to place, and these are our references, and that was from our side. Thank you.
Thank you, speaker, for the presentation. Audience members, do you have any queries? Okay, no queries from audience. I have no questions. Okay. The session chairs do not have any queries. So thank you for the presentation. We can move ahead with the next one. So the next presentation is from team number 44, and the name of the speaker is Akshit Dhruv, and the paper title is Real-Time Sign Language Converter for Deaf and Mute.
Share.
That's fine. That is also fine. If you will,
Yes, it's fine. We can see.
yeah.
Yes. So the
Just speak loudly so that it's others.
yeah. So the research paper is based on the real-time sign language converter for the mute and the deaf people. Next slide, please. Yes. So the abstract of the research paper is that it is aiming to develop a system which can convert the speech to text for the deaf people. And also, like suppose if the deaf people is not able to understand any language, then at that time it will convert that text to the sign language. Similarly, for the mute people, if the sign language, whatever they will try to do, that will get converted to the text and simultaneously it will get to the speech. So that we have used the technology of machine learning, AI concepts and the natural language processing, which will make the model accurate. Next slide. Introduction. According to the report of WHO, around 466 million people in the world has a problem of hearing loss. So this innovation will help not only the few people, but around 466 million people who are around the world having the hearing loss. And there is not a complete figure for the mute people. But according to the approximation, there are around 1 of every 10,000 has a problem of the mute. Next. Yes. So by the research, we have tried to cover these three main prospects. The first one is to create a feasible model. Because if it is feasible, then only the people who are deaf and mute will be able to carry it. The second is the accuracy. Like if it has the higher accuracy, then only the people will able to have a trust on this model. So from our research, we have got the accuracy of 96%, which is higher than the any existing model. We have developed this model and we have made it into a single model that will reduce the complexity. Next. Literature survey. The main prospects which require is the speech enhancement. Suppose at the time we are speaking, if there is no enhancement done, then at that time there will be a problem. So the speech enhancement done by the researcher A. Narayan has done the using the different layers. He has used the 9-layer prospects of CNN models, and using that they have developed the two different methods, that is the ideal binary mask system and the ideal ratio mask system. Using the ideal binary mask, it will improve the speech intelligibility, while the ideal ratio mask will help in the improvement of the quality. So we have combined these two methods and we have added our own method. So this will help it in the process. Next. The second complexity which we faced was the speech to sign language converter. As it is the complex part, like not everyone speak uniformly. So for that, the research conducted by Stoll et al. Shows the conversion of text to speech. In his proposed method, he has used the neural machine translation methods. So we have not just used the neural machine translation method, but along with it, we have used the artificial intelligence and the whatever drawbacks which this paper had, we had tried to overcome it. Next. The flowchart of the research which we have proposed it, if the input voice will be entered, at that time if the person is deaf, then the conversion of speech to text will take place. Now, if the user is able to understand any single language, then at that time the text will get converted to the sign language. And if the person is not able to understand, then it will directly give the output. And if he is not able to understand, then it will get converted to the sign language. Similarly, for the mute people, the message will be conveyed using his sign language, and that sign language will convert it to the finally the voice. Next. So the model for the new people who are born deaf. So for them, the first of all speech, like suppose the one who is talking to him, that will get converted by before that the noise removal process will take place and the pre-processing of the audio will take place. After that, that speech will get converted to text, and for that we have trained the neural network using the deep learning and the natural language processing. And after conversion of speech to text, we have converted the text to the sign language, and for that we have used the machine learning to predict the answer. Model for mute people. For this, we have used the camera and the technology of a CV2 that will help to read the data, and using the Python, we will be able to detect the hand gesture. we have used the data augmentation. The main purpose of using the data augmentation is to increase the size of the data set. After that, we have used the sequential model as there are no interdependence between any layer. So we will be using the sequential model and that will help it. And after that, we have used the ADAM optimizer to get the loss value and to increase the accuracy. And for the conversion of text to speech, we have used the which is existing method of the Google Text to Speech API, which is also known as GTTS API. Next. The resultant analysis which we have conducted, the left hand side will show, right hand side will show the actual sign language, while the right hand side will show the predicted one. So you can see that we have got almost all the correct answers. Next. So like we have used the different methods and tried to achieve different types of accuracy. And we found that by increasing the data set values and the extending the training data set, we got the approximately 100% accuracy. Next. The conclusion is that this model will not just complete the requirement of the deaf and mute, but this will also bring the innovation in them. Next. References which are as per the paper. Acknowledgement. I would like to express my deep thanks to AIMV 2122 Conference Committee for giving me this opportunity. Also, I am grateful to my co-author, Dr. Santosh Bharti sir, who guided me throughout this project. Thank you.
Thank you, Akshay Dhruv. It was a nice presentation. Audience members, do you have any queries? Okay, so no queries from audience. I have a couple. So you have mentioned in one of the earlier slides that you have achieved feasibility in your work. So could you please explain that a little bit?
Yeah, so feasibility in the sense that both the model requires the conversion of speech to sign language if the person doesn't know that thing. So like if we create two different models, then that process will be long. But if we combine that both the process, then the time required for learning the process will be less. And also the feasibility contains two types, like we can do it in the two different models also, and we can combine this also.
Okay. My next question is that one of the steps that you have done is you have augmented your data.
Yes.
So how much data set you had originally used?
I had a data of around 10,000. That also I generated using the CD tools only.
Okay, and means was 10,000 not sufficient? Why did you decide to augment?
Because by using the 10,000 data, I got the accuracy of 85%. And actually, I was not satisfied with that, so I tried the data augmentation, and that helped really to increase that thing.
Okay. Okay, no more questions from my side.
Yeah, so I have two questions.
Yes.
You sorted result, right, where the sign language is converted to number.
Yes.
So there were only 10 signs.
Yes.
Corresponding to digits.
Yes.
I wanted to know how many different signs are there, hand signs are there, and gestures are there in actual universal sign language.
There are around, for the numbers, there are around
numbers.
Okay.
How do they communicate? There should be something more than numbers, right?
Yes, they have a predefined language, universal sign, and there are around more than 3,000 words. 3,000.
Okay.
And from that, we tried to work upon around more than 1,000.
1,000.
Yes.
So why only 1,000? Why not all?
Like we got the accuracy, and we also are working on this. So just now we had a data of around 1,000 for the training purpose. So we are working on it, and as soon as we get the more data, we can work upon the next 2,000 data.
Okay, so data availability was
very less in this field. Yes.
Okay. Second question I wanted to ask is, can you please go to that slide where you explained the speech to text conversion, the model for the deaf people, I guess.
Okay.
Yeah, the previous slide. So for this, you have used the CNN, right?
Yes.
For this?
Yes.
For speech to text conversion, you have used CNN.
Yes.
So is it a one-dimensional CNN or two-dimensional?
Here we have used the three layers. The first layer is for the purpose of the first we have used the three, out of which the two are for the processing one and the third one is for the output purpose.
Okay, so what data have you used for training this network?
For this, there is a inbuilt data from the BBC English to sign language converter. So that permission was granted to me, and I have a permission from that.
So right now your model only works for English to other language.
Yes.
Converting it to other language.
Yes, definitely.
The input cannot be accepted from any other language.
Yes, but this has the feasibility that it has the code design. So as soon as we get the training data set for any other language, or if the requirement is for other language, then we can train the data and we can work upon it. So it will require the less time as compared to designing from the new or the basic level.
Okay, and okay, so no more question from my side.
Thank you.
Okay, thank you everyone. With this, our session has ended. I think we can leave.
Everyone can leave the meeting.